Hello everyone. Now today I am starting predicate calculus. What is mean by predicate or predicates? We will see with some simple and small examples what is predicate, what is subject, how to denote, how to write, how to symbolize the predicates, everything we will learn today. Now with simple examples I will explain the predicate calculus. Consider the statement. I'll give you one statement. Zahir is a bowler. Here, bowler is called predicate and Zahir is called subject. Zahir is called subject and bowler is called predicate. Now, the above statement we can denote this one as B of Z. B of Z. Whatever the predicate we have to denote with capital letter and subject we have to denote with a small letter. Here Z is the letter which denotes Zahir. B is the letter which denotes predicate. Therefore, we have to denote the predicates with capital letter and subject. The subject we have to denote with a small letter. B of Z. What is mean by B of Z? Zahir is a bowler. In the same way, we will see few more examples. The statement, this cricket ball is white. We can symbolize this one with W of B. Here, W is the predicate, is white. W is the predicate, is white. B denotes the cricket ball. That's why W of B. Predicates we have to denote with capital letter. This cricket ball is white. I'm symbolizing, I'm denoting with W of B. Is white. The knowing the is white is a predicate and ball is a cricket ball is a subject. The next one, the statement, Jack is a bachelor and this painting is red. The statement is Jack is a bachelor and this painting is red. Can be written as B of J and symbol and R of P. That means what is capital B? B of J. B of J. Jack is bachelor. Jack is bachelor. Just reverse. Jack is bachelor and that painting is red. Just reverse. Jack is bachelor and that painting is red. In the same way, in the above also, the ball is white. The cricket ball, whatever the ball, the cricket ball is white. Now B of Z, first one, B of Z. B of Z means Zahir is a bowler. Just reverse. B of Z. Now in the same way, Jack is a bachelor and this painting is red. This statement we can write, we can symbolize or we can denote this statement. Jack is a bachelor and this painting is red in this form B of J into R of P. Now in the same way, statements involving the names of two objects such as names of two objects. Sometimes we will have such type of statements. See, for example, Jack is taller than Zil. Jack is taller than Zil. Such type of statements. Or Canada is north to United States. Canada is north to United States. Now, such type of predicates. Two names we have got, Jack and Jill, Canada and US. Such type of predicates, how to denote, I will tell you. Now, the predicate is taller than and is north of are two place predicates. Because the names of two objects are needed to complete the statement involving these predicates. Such type of predicates, how to denote, I will tell you. Now, G of the above statement can be symbolized as G of J1, J2, J1, J2, where G denotes the predicate is taller than. G denote the predicate is taller than and J1 denotes Jack and J2 denotes Jill. G of J1, J2. That means G is a predicate is taller than. That's why Jill is taller than J2. J means Jack. Now N of C, S. N of C, S. N denotes the predicate is north of, is to the north of. N denotes the predicate is to the north of. C denotes Canada and S denotes United States. N of C comma S means Canada is north of, is to the north of United States. Now another one. Now very important, two important definitions to do the problems as well as important definitions. Universal quantifiers and existential quantifiers. Now we symbolize, what is mean by universal quantifiers? I am explaining. We symbolize for all x by the symbol like this, by the symbol for every x, for all x or within brackets x, both are same, either this or this. For all x or within brackets x. This one we are denoting this one with for all. Instead of for all x, we can denote like this or like this, with an understanding that this symbol be placed before the statement function which is the phase is applied. That means this is called universal quantifier. For all x is called universal quantifier. Now for example, I'll give you one example. Now if, for example, m of x, x is a man, m of x, it is a predicate, x is a man. Now h of x is clever, h of x is a clever. This is a one statement. Then we symbolize for all x, if x is a man then x is clever. For all x, if x is a man then x is clever, as we can symbolize this statement as for all x, m of x, if m of x then h of x. This is a conditional statement, arrow, conditional statement. For all x, if m of x then h of x. That means if m of x means if x is a man then x is clever. If you understand this one, a conditional statement, if p then q, like that. If m of x then h of x means if x is a man then x is clever. For all x means for all man. If x is a man then he is clever. Now the second example, if p of x, what is p of x? It is a predicate. X is a pen. B of x, x is blue. P of x means x is pen. B of x means x is blue. Then we symbolize this one. For all x, x is a pen, then x is blue. For all x, x is a pen, then x is blue. We can write in this form. For all x, if p of x, then b of x. Conditional statement. If p of x, then b of x. What is the meaning of this one? In words. What is the meaning in words? For every x or for all x, if x is a pen, then x is blue. Like that. This is example of a universal quantifier. The symbol for all x or for every x or for all x are called universal quantifiers. This symbol is called universal quantifier. These two are the examples. The quantifier symbol for all x, for every or the closed bracket. This is the symbol of a universal quantifier. It contains the variable which is to be quantified. It contains the variable which is to be quantified. This is about a universal quantifier. Now another quantifier is there. It is called existential quantifier. Existential. Another quantifier we will introduce to symbolize the expression such as for some. Now the previous one is for all is called universal quantifier. Here for some or there is at least, there exist, all are same meaning. For some or there is at least one, or there exists some. All are with the same meaning. The symbol is like this. There exists x. Within brackets, there exists x. Now, another quantifier. For some, you can, the same meaning. For some, or there is at least one, or there exists some. It is denoted by with this symbol. This is called existential quantifier. Now, one example we will see. Some men are clever. Some men are clever. P of x, x is a man. P of x, x is a man. Q of x, x is clever. Now we can symbolize using the existential quantifier. There exists x. There is at least one x. P of x and symbol. And Q of x. There is at least one man. If x is a man and x is a clever. The meaning of this one. We use the existential quantifier which are of the form some P or Q. Now we will see few problems using predicates. Now the first problem is every student, we have to symbolize these predicates. Every student in this class has studied logic. This is one statement. Now we are going to symbolize this one. Let P of x, we are assuming P of x, x studied logic. Q of x, x is in this class. Now then we can symbolize using the universal quantifier as for every x, if Q of x, then P of x. If Q of x, then P of x means for all x, if x is in this class, he studied logic. If x is in this class, then he studied logic. The second example. Some cats are black, but all buffaloes are black. Example. Some cats are black, but all buffaloes are black. Now, let C of x, x is a cat. B of y is a buffalo. B of x, x is black. To write this statement to predicate, I am using small predicates like this. Now, there exists at least one x for every y, C of x and B of x, and if B of y, then B of x. What is the meaning of this? There exists at least one x for every y, C of x, x is a cat and x is black. X is cat and x is black, and if y is buffalo, then x is black. Y is buffalo, then x is black. Like that we can symbolize this one. The third one, every student in this school is either good at studies or good in sports. Every student in this school is either good in studies or good in sports. Now here to do this one, S of x. What is S of x? X is a student of this school. What is P of x? X is good at studies. What is Q of x? X is good at sports. Now we used every, that's why for all x, if S of x, then P of x or Q of x. Like this we can symbolize. The next problem is all cats are animals. All cats are animals. Now to do this one, C of x, x is a cat. A of x, x is an animal. What is it? For all x's, if C of x, then it is A of x. If x is a cat, for all x, if x is a cat, then X is an animal. Next one. Every mammal is warm-blooded. Every mammal is a warm-blooded. M of X. X is a mammal. W of X. X is warm-blooded. For all X, if M of X, then it is W of X. If M of X, then it is W of X. The next one. Every book with this, every book with blue cover, every book with blue cover is maths book. To do this one, B of X. X has a blue cover. M of X. X is a maths book. For all X, if B of X, then it is M of X. If conditional statement, if B of X, then it is M of X. If X has a blue cover, then X is a maths book. The next one, root 3 is not a rational number. Root 3 is not a rational number. How to denote this one? This is negation symbol. Negation. Negation of there exists some x, q. Q denotes rational numbers. X square is equal to 3. X square is equal to 3 means x is equal to root 3. Negation. Root 3 is not a rational number.